Welcome back. This is the second half of the 3.1 video. And in this part of the video, we're going to talk about function notation. So in the first video for section 3.1, I should have 3.1 written here. In the first video for 3.1, we talked about how to recognize a function. And in this video, we're going to talk about function notation. Function notation is just a handy way that mathematicians have come up with to work with functions. And the basic function notation is y equals f of x. This read f of x, and it's not multiplication. That's not f times x, not multiplication. It's f is a function of x. So in generally we say f at some input equals some output. Let's practice using function notation. So here is our example that we're going to use function notation with. All right, so we have a function f of x equals x squared minus 2, and we're going to evaluate if the following values of x. So the first one is f of 2. So a function is just a rule that tells you how to manipulate a variable. It tells me f of x equals x squared minus 2 tells me that whatever my x is, I want to square it and subtract 2. That's what that rule is telling me. So if my x is 2, I'm going to square 2 and subtract 2. So everywhere I saw an x, I put in a 2. And now I use my order of operations, which is PEMDAS, and I need to go parentheses exponents. So that's going to mean to do the 2 squared first, which is 4. 4 minus 2 is 2. So f of 2 equals 2. I can write that down here a little more neatly. So if my input is 2, my output is also 2. All right, I'd like you guys to try f of 0 and f of negative 2 right now. Pause the video and try to plug in 0 and try to plug in negative 2. All right, let's give 0 a try together. Hopefully you paused the video and came back. So now, instead of plugging in 2, everywhere I see an x, I'm going to plug in 0. So 0 squared minus 2. Well, 0 squared is 0. 0 minus 2 is negative 2. So that tells me that f of 0 equals negative 2. All right, let's try f of negative 2. Negative 2 squared minus 2. Now, you may have been wondering up to this point why I've been putting parentheses around all my values when I substitute them. And it really wasn't necessary in the first two examples because both of those values were positive. But what you need to do, you need to notice here is it really is necessary on this example. Because, now this is wrong, so don't do this. If I didn't write in the parentheses, I would have written negative 2 squared minus 2. Now, if I looked at my order of operations, I would have done the square part on the 2 first before the negative. That would have given me negative 2 squared, which is 4 minus 2, and my final answer would have been negative 6. See, but that's not what I want to do. The function tells me to square my input, so it wants me to square the whole negative 2. So don't do this. Don't do that. Bad news. Put parentheses around anything you're subbing in so you're sure to get that order of operations correct. Negative 2 squared is negative 2 times negative 2, which is 4, minus 2, which is 2. So f of negative 2 is 2. And the last one here is just a little fun one. You don't have to plug in a number into a function. You can plug anything you want into a function. In fact, later we'll be plugging functions into functions. But right now, let's see if we can figure out what f of x circle is. All right, well, before, everywhere we saw a x, we put in a 2 or a 0 or a negative 2, whatever was in that parentheses. Now, everywhere we see an x, we're going to put in an x circle. So x circle squared minus 2. So that's where we're heading in this class. All right, so let's talk about evaluating functions and solving functions. There's sort of two ways we do this. Maybe in one choice, we know the input, we need to figure out what the output is. And the other way would be we know the output and we'd like to solve for the input. We're going to do a simple, pretty straightforward example for both of those. So here's my first one, f of t equals t plus 1. And I'm using a different variable. You don't always have to use x. And let's plug f of 3. This should be easy for us, hopefully after what we just did. Everywhere we see a t, we're now going to put a 3. So f of 3 equals 3 plus 1. So f of 3 is equal to 4. So my rule is take my input and add 1 to it. Now let's go over and look at this guy over here. In this one, we don't know what t is, but we do know what f of t is. And we know f of t is equal to 3. So instead of substituting in for my t, I'm substituting this whole bit in for f of t. So I would say 3 equals t plus 1. Solving this for t gives me 2 equals t. So this tells me that if I want an output of 3, I need an input of 2. So I can write that f of 2 equals 3. All right. Let's see if we can do inputs and outputs, not from an equation using function notation, but using function notation but reading the values from a table. So the table below represents a function d of m, where m represents the month number, i.e. January is 1, February is 2, and d represents the number of days in that month. So let's evaluate d of 2. So remember here, this is d of m. This is telling me m equals 2. So I come up to my chart, and I see when m equals 2, d of m equals 28. So d of 2, oops, my computer hung up there for a second. D of 2 equals 28. Then let's interpret this result in the context of the scenario. Let's take a second to really think about what those instructions mean. Whenever you see interpret in the context, I don't want to hear about numbers and x's and y's or m's and dm's. I want to hear about words that are representing the variable. So m is the month and d is the number of days. So when I interpret that in the context of the situation, I want to make sure that I'm talking about months and number of days. Hopefully we all can understand that this means in the second month, that's the m equal to 2, there are 28 days. And a sentence like this is what I am talking about when I say to interpret in the context. All right, let's look at this one. Evaluate d of m equals 30, then interpret this result. So now I want to know when my output is equal to 30. Well, let's look at my chart and see when my output equals 30. Well, here's one. Here's another one. Here's another one. And one more. So there's 4 times that d of m equals 30. I know that d of 4 equals 30. I know that d of 6 equals 30. And I know d of 9 equals 30. And d of 11 equals 30. Now I want you to pause the video and write down your interpretation of this result in the context of the scenario. All right, I hope you guys wrote down your sentence. Did you write down a poem? I'm going to write down a poem that you guys may have heard. 30 days hath September, April, June, and November. Did you guys learn this poem in school? Maybe not. I did. You didn't have to write it that way. You could have written, there are 30 days in the 4th, 6th, 9th, and 11th month. That would have been fun. I just thought a poem would be fun. Alrighty, let's do one more of interpreting, and let's do this one from a graph. So we've done it from an equation. We've looked interpreted function values from a table, and now we're going to interpret function values from a graph. All right, here is my function f of x. It says let y equals f of x. What is f of 0, f of 6? Label the points on the graph, and we're going to assume each line is 1 unit away from the next. So this graph doesn't have a good axis label. I'm just going to go ahead and label it right now because I think it is very important to make sure that we label the graphs so we know what we're talking about. 1, 2, 3. A well-labeled graph can save you a lot of pain and suffering. All right, now the first thing they're asking me is what is f of 0? So this means my input is 0. What is my output? Here's 0. At 0, I really wish I could change colors, but I can't seem to get my pen to come up since I started videoing. Or maybe I set it right over this thing. Oh well. All right, f of 0. Here's 0. When I go to 0 and I look up, my f of 0 value is 2. This is the point x equals 0, y equals 2. It's on the graph. So this tells me if x equals 0, y equals 2 is on my graph, that means the same as f of 0 equals 2. All right, let's see if you can do the second one. Can you guys look on the graph and see what f of 6 is equal to? Pause the video and try it. All right, hopefully you went over to input value of 6, x equals 6, and you found on the graph 6, 1. So that tells me that f of 6 equals 1. The 0.61 is on the graph, f of 6 equals 1. All right, now that was given an input, what's my output? Now I'm asking, well, when is f of x equal to 0? So this is saying, when is my output equal to 0? So this is saying, when is y equals 0? X equals what when y equals 0? Well, when does y equals 0? When we're not up or down. So y equals 0 exactly right here. I should have labeled it at -3. So this is the point x equals -3, y equals 0. So that tells me that f of -3 equals 0. Remember, if it's a point on the graph, x, y, then f of x equals y is a way to use function notation. All right, we have one more topic for today, and that is one-to-one functions. One-to-one functions mean that there is a unique input, that for every unique input, there is only one unique output. So if there's one input for every output, one output for every input. One-to-one functions conveniently have a really nice test as well, similar to the vertical line test, and it's called the horizontal line test. All right, so what does that mean? Let's look at an example of a one-to-one function. It says each input, for each output, there is only one input. So let's see if I can draw a one-to-one function here. Let's draw a nice curve. So if we want to pass the horizontal line test, we know that anytime we draw a horizontal line, it can only touch the graph of the function once. So this nice kind of cubic guy that I just drew here, it passes the horizontal line test and is a one-to-one function. Sometimes people write it like that, one-to-one. Let's see if we can draw one that is not one-to-one. What's not going to pass the horizontal line test? Let's draw a nice parabola. Parabolas do not pass the horizontal line test. I mean, you can use the x-axis right away, but any of these horizontal lines is going to hit the graph in more than one place. And what that means is that the output, let's say this is at -2, happens at, let's say this is at 3 and -3. The output of -2 happens both for the input 3 and for the input -3. So it is not one-to-one. -2 has two different inputs that lead to it. So don't get that confused with all functions. There's one-to-one functions are a special subset of functions that pass the horizontal line test as well. To be a function, you only need to pass the vertical line test. So both of these guys are functions, but only this guy is one-to-one. This is not one-to-one, still a function. So what I would like you guys to do now is go into MyOpenMath. I usually use the acronym MOM for that. And I want you to look at the toolkit functions. It should be listed in the block for what's due on right around section 3.1. And I want you to list all the functions in there that you think pass the horizontal line test. All right, that's the end of this video, and see you next time.